So we're going to go over your quizzes in your geometry quiz 32. So let's begin, and going over it, I hope I kind of went over some of these already. So you should know the answers, hopefully. So we're going to do it together. So the first says, name the proportion transformation used to change each of the following. I went over those transformations. So this first one's a little tricky. It's like, start with a tricky one, but here we have 2/3 equal 8/12. Can you read that on there? So 2/3 equal 8/12. Basically, the transformation is how are we translating this onto 5/3 equal 20/12. So when you look at that, you think, so how is 2/3 transferred into 5/3? Well, if you look, 2 plus 3 equal 5. So 2 plus 3 equal 5, so what? 5/3 right here. And then how about this one? 8 plus 12 equal 20, 20/12. So we have addition. So we're basically having your addition transformation. So as you remember that addition transformation, so put down addition because we're adding. On to number 2. Now these are a lot easier. So we have AB, so if you can see it, AB equals CD into AC equal BD. So what are we doing? Looks like they're trading positions, right? A to C now, so A to C and B to D. So they're transferring AB to AD. So they're transferring, the A and the C are going together now, and the B and D are going together. So we call this alternation because you're alternating partners, right? That's what I call it. So on to the next one is AB to CD into BA to BC. So what are we doing now? Well, we're changing AB into BA, so we're inverting them. The B's on the top now, and the A's on the bottom. The same with the CD. We're changing the D and the C around. So we call this inversion. Inversion, we're just taking the bottom number, putting on the top, and the top number on the bottom. So we call that inversion transformation. Number 4, name the first term in a ratio. This was back in just your terms that in the beginning of the chapter, so you can look it up. But the first term, that's the A. What do you call the A right here? You call that the antecedent. The antecedent means first, or numerator. You have a numerator and a denominator. So this top one is either called the antecedent or the numerator. Number 5, give the term for an inequality of ratios. So what are we talking about this whole time? Equality. I said inequality. Equality of ratios is a proportion. So give the term for the equality of ratios is a proportion. So on to this one. I'm going to do these because I solved them here. Solve for x. So we have solve for x, 5/7, x over 35. So I did it a little bit bigger here so you can see the work. So you need to put your work here. So hopefully you can see this. So basically, let's move it up a little bit here so you can see it better. How about that? Maybe a little bit more up. So here we have solve here, solve for x. So we have 5/7 and x over 35. So just do the cross multiplying. 5 times 35 and x times 7. So I have 7x, and I did over here, 5 times 35 here, I figured it out right here, is 175. So 7x equals 175. Well, now I need to divide 175 by x. I did over here, and I got 25. So if you solve for x, x is going to equal 25. Very easy one. Let's go on to the next one. This says solve for x, 3/4 equal 12 divided by x minus 3. So I wrote it right here. So let's go on to this next one here, number 7. I wrote it out. So you have 3/4. So basically we cross multiplied 3 times x minus 3 right here equal, and 4 times 12 is 48. So I have 3 times x minus 3 equal 48. So then I use the associative property of doing 3x minus 9. So I change that. 3x minus 9 equal 48 now. So now we can get rid of this 9. So we add it to this side. So 48 plus 9 is going to equal 57. So now I have 3x equal 57. And x, if you divide it here, which I did, you can write this in too, is to divide it out. 57 divided by 3 is equal, basically equals 19. So 19, there you go. So x equals 19, that's your answer. X equals 19. You have to show your work there. So number 8 says to find the fourth number. So let's go ahead and do that. And number 8. So here we have 2, 5, and 8. So 2 is the first number. So 2 is the first number. The second number is 5. So you have 2 over 5 and 8 over the last one is D. That's the fourth proportional. So then you do cross one. You go 2D. You can see this. 2D. Let's move it up more so we can kind of down here there. 2D. 2D equal what? 5 times 8 is 40. 2D equal 40. So we're going to just divide both sides by 2. And we got D equals 20. So our answer is going to be 20 for number 8. Just to know that the fourth proportional is going to be 2 to 5 to 8 to D. You know, it's going to be the fourth number like this. Okay. On to this one is a little bit, because you think, well, what is the mean proportional? The mean proportional is going to be the middle number. So, and the mean proportional is going to have two x's. Mean means the two middle numbers. So here's to find the mean proportional right here. Let's look at right here. The mean proportional is of 3 and 12. So you have 3 is the first proportion, will be A. 3x, we don't have it. We don't know what that is. And we don't know what this proportion is. They're going to be the same number though, because the mean proportion, these are the extremes and these are the means. They're equal. So now we're going to multiply them out. So here we have 12 times 3 is 36. So 36 and x times x is x squared. So 36 equal x squared, or you're going to take the square root of 36 is going to be 6. It can either be a negative or positive 6. So the mean proportion is going to be a positive or negative 6. So right there I put it, positive or negative 6. So this last one is in the space below. Use the fundamental property, that's that cross multiplying of them, to show that 3/5 equal 36 over 60, right? And so here's how you did it. Basically you say 3/5 equal 36 over 60, you do the cross multiplying, which is 3 times 60 equal 180, and then 5 times 36, which I did right here, and that equals 180. So put down 3 times 60 equals 5 times 36, or 180 equals 180. So you're just showing that that works, okay? So that's that quiz. Not too hard. A couple of them, the one that I didn't get at first was this mean proportional, but as you figure it out, it means these two numbers. So if you look at this, 3x over x, and then you have to multiply it and you get an x squared. That's why it's plus and minus. Whenever you plus and minus, you're dealing with square roots, right? So let's go on to the next quiz. Okay. Kind of did a lot of scribbling here, so I'm going to show you how to do them. So okay. Oh, let's move down. All right. So quiz 33. Solve for the required line using the diagram beside each equation. I did the diagram again just to see it better, because when I first did it, I just my chicken scratch there kind of. So basically you have number 1, DE, and I just copied here. DE is parallel to AB. So you have a triangle here, and AB is the line AB, and it's parallel. So that means this triangle, this big triangle, is similar to this little triangle because they're both parallel. So basically this triangle is going to be similar to this triangle. So, and now we can find a proportion, because if they're similar, they are in proportions. So they tell you which each one of these. It says CE equals 6. So I wrote down, you make sure just put it right on here. Right on here. Put down 6. So CE equals 6. So you put a little 6 there. Know exactly what that line is. This keeps it so you don't get mixed up. And so then it says BE is 3. So BE is this one, and this one's 3. So this is 6 and 3, but we're going to need what the big triangle is, so I went ahead and put down 6 plus 3 equal 9. So this whole line is going to be 9, and this is 6 and 3. So on this side, we have then AC equal 12. AC is this huge line equals 12. Now they want you to find what this line is. So how do we do that? We're going to have a proportion then, right? So our proportion is going to be, we have basically to know that this proportion, this big line is going to be proportion to this line. The 12 to the 9 is going to be the same, 12 and 9 and 8 and 6. So, but, so we're going to know that's 8. We don't know this yet. I found that out. So first of all, I have 6 to 9. 6 to 9. That means this to this big one. That means this little triangle here, 6, to the big triangle, which is 6 to 9, right? And then we have x. We don't know what this is 8 yet. I put 8 in there because I found it out, but this is going to be x to 12, so I put x to 12. And now I do my cross multiplying here. And so I have 6 times 12 equals 72. So 72 equals 9x. So what's x going to be? Okay, so we're going to basically divide 72 by 9 and we get 8. So x is going to be equal 8. But that's not our answer. That's this answer up here. That's this little one. It's going to be 8. But we want to know what this one is. That's the one. So we know that this is 12 and this is 8. So 12 minus 8 is 4. So AD has to be 4. 4 is the answer. See how that is? I figured this basic 6 to 9, do all this, but follow along here. This is how I basically 6 over 9 equal x over 12, which I kind of did here. I changed that to 2/3, but forget about that. That's a long way around. So basically just put 6 over 9 equal x over 12, and then we find out that x is 8. So we have 8, and then you're going to say 12. 12 minus 8 is 4, so this answer is going to have to be 4, and this is what we're looking for right there. Okay, number 1. There's only a couple problems here, so let's go on to number 2. Number 2. Okay, so I drew it again because I want to go over it easier so you can see what I'm doing. So we have x. If x z equals 6, so here we have we have two angles. There's our two triangles here. We have this triangle and we have the big triangle, right? And we actually have 3 triangles because we have this triangle, and so we know when there's an internal division, when this is bisecting these two and this angle, we know that we have an angle there. So these 2 triangles are going to be similar. Now we're going to have to turn them maybe to make them similar, but they're going to be similar. So anyway, so I said this triangle is going to be similar to that triangle. So now it's pretty good. So now let's fill in. It says xz. Here's xz equals 6. So I put 6 there. And yz, yz here equals 12. So this equals 6 and this equals 12. Okay. And then xw equals 3. So since these are proportional, we can make a proportion. Basically, this line, 6 to 12. So I put, can you see this? Hope you can read it now. So 6 to 12. 6 to 12 equals 3 to whatever this is. So I didn't put x there because there's x, y, z are the numbers. So anyway, I put down 6 to 12 equal, and basically 3 to x, right? I put x there, but I have a question mark there. So 6 to 12 equal 3 to x. X is our placeholder, so 6 times x, 6x equal 36. And so at 6x equal 36, you divide by 36 by 6, and x is going to equal 6. So we found that x is equal 6. But what line are they asking us for? We know that this line here is 6, and this line here is 3. So they want to know what xy is. Well, look at xy is going to be 6 plus 3. So xy is going to be 3 plus 6 here equal 9. Okay, that's number 2. Number 3, okay, is going to be a little bit harder because it's hard to figure, and I wrote this out. It says, let's write it here. I did it over here better, so let me move it over here so you can see better. I did it over because I kind of made a mistake on that one. Here's the question right here. Okay, see that? So it says if FH equal 10, so here's what that picture that you have, right? So if FH equal 10, which it did, and then GH equals 6, this line is 6, okay? And then we have GJ equals 15, GJ equals 15. Those are what they gave us. But they gave us a thing, basically, that this angle and this angle are alike. So that means that gives us that there's a similarity that we're gonna have to deal with. And basically, that similarity is going to say the bisector, an external bisector, and that's what that is. This is an external bisector, bisecting this, this, and this. This is an external bisector, divides the opposite sides, the same ratio of the other two sides of exterior angle bisector. So this is very, like, what sides are they talking about? You know, that's what I thought at first. So basically, we're going to know now, you know, as for this, basically FG to FJ, these are what they're talking about, opposite sides. These two here, and then these two, or these two here. So since we have 10 and 6. And so now we know, okay, 15. 15 to what? This whole thing is going to be x, right? So 15 to x. So 15 to x. Right here. I'll say 15 to x equals 6. 6 is here to 10. So 15 to x equals 6 to 10. And so now we can say 6x equal 150, right? 6x equal 150. So now we're going to divide 150, which I did down here, 150 by 6. To find what x is. So I divide it by 6, and I got, I don't know what that number in there, and I got the number 25. So, yeah. Forget about this. I don't know what I wrote this here. So, 156x. So, all right there. So anyway, there we go. And so we have, the number is going to be 25. What number is 25? Well, x is going to be 25. This big number, this is going to be 25. So we have that number 25. But what are they asking for? They're asking to find FG. They want to know this number. So if this whole big number is 25, then this number here, FG, which we're looking for right there, what's that number? That's the number that they want. So basically, 25 minus 15 is 10. We find that number 10. So your answer is going to be 10. Okay? And that's what I got here, the answer 10. In the midst of this answer is 10. But the thing about this whole thing too, with this answer, you know, the answer as the answer being 10, you actually can take, since for a right triangle, you could take the Pythagorean theorem and figure out that number too. And we'll do that later, but that's not in your thing. But basically, this answer is going to be 10. Make sure you put all of this in here. Don't put this little thing in there. I don't know what that is, but just how we found the number 25. And then we know at the end we put 25 minus 15 equal 10, right? 10 is our answer. Make sure you put your work there. Okay, let's go back to the proof. This actually proof is a pretty easy one, so that's good. It's only a couple steps. So when you look at, oh no, a proof, you know, so here we have the proof here. We have AC is parallel, it's a parallel mark to BD. So this here is parallel. So now if we have parallel, we know that anything that crosses the parallel line will have alternate interior angles or alternate exterior angles. Or when so here we have this line is transversing, right? See if I can put that right like there, that's transversing. So we know then that if this is transversing, then this angle right here, this angle is going to be equal to this angle. Right here, those two angles are going to be equal. And so we have another transversal coming this way. So now we know this transversal, basically, as we go, just this angle here is going to be equal to this angle, because it transversed these parallel lines, right? So we have, in this little triangle here, we have angle there, and this triangle right here, we have two angles. So we have two angles in this one and two angles in this one. And whenever you have two angles, they're going to be similar, right? Look in your problem, you'll find two angles will be similar. So first of all, you do the given, AC is parallel to BD. Then you have angle A equals angle B. This is angle A equals angle B. You have angle C equals angle D right there. And so now you have two angles, so you call that AA. If two angles of one triangle are equal to two angles of another triangle, they are similar. Okay, so write that out. So let's go on, let's see. I am going to do this quiz separately because it's kind of a long quiz as it looks like. So let's do this one separately and then we'll go on to the test.